solving equations of basic logarithms. So the process is identical to what we did before. We just are starting out with logs. We're still going to use the uniqueness property and the inverse properties. Alright, so again, first thing is the log term should be isolated to one side. And this one, again, for most of these, I'm going to go ahead and I think all but one of them start out that way. And then we use our inverse property. Alright, so we've got our first one here, which is our log base 9 of x equals 3 halves. Now, you could just rewrite it, and that's fine, but I'm going to use my log properties and my inverse properties. Take both sides, and remember, it's both sides raised to. So it's 9 raised to the log base 9 of x. So on the other side, it's 9 raised to the 3 halves power. And so this side is our property where they undo one another, so x equals 9 raised to the 3 halves. Which if you type 9 raised to the 3 halves in, that comes out 27. Right, then with logs, we always have to check logs. Alright, check that we don't get any negative numbers, and so we have to check this. Can I plug 27 in? Yes, I can plug 27 in, it checks. So you should always check your answer, because there are some times, now, for the basic cases, it doesn't happen as often. When we get to the next section where we get more complex equations, those are the cases where we will throw them out. We always have to check. Remember, logarithms, we can only plug in positive numbers. So if my x value came out negative, we throw it out and say there's no solution, because it doesn't work. Alright, next example. So this is log, and remember, when it's just log, it's understood to be log base 10. And so I'm going to raise it to the 10. Whatever I do to one side, I have to do the other. So the log base 10 raised to the 10, cancel each other out, leave me with x. On this side, it's 10 raised to the third, which is 10 cubed, comes out 1,000. Alright, my answer. And it checks. I can plug 1,000 in. Alright, log ln, so it's the natural log of x, which remember, natural log of x is just the log base e of x equals negative 2, and so you raise it to the e. So I wrote it out there, but I'm going to go back and rewrite it natural log, which again, I take it raised both sides to the e. E raised to the natural log of x undoes one another, the other side is e raised to the negative 2. And so x is exactly e raised to the negative 2, and then I have to plug e raised to the negative 2 into my calculator, and it's a very small fraction, 0.135. I round 3 decimal places, and it does check. I can plug that in. Alright, next example. Log base 4 of x is equal to 3.7, so it's base 4, so I raise both sides to the 4. That side cancels out, 3, so x is equal to 4 raised to the 3.7, which again, I'm going to find my approximate answer. So 4 raised to the 3.7 comes out 168.897 if I round 3 decimal places. Alright, the next example. So I've got log base 3. 5x equals, so this one's going to be a little more complex because there's a 5x inside. First part's the same though. I get rid of the log by taking it to the 3. So 3 raised to the log base 3 is going to leave me with a 5x on this side. And then on that side I have 3 raised to the 10th power. And then I divide by 5. Alright, so x is 3 raised to the 10 divided by 5, and so this is going to be a pretty big number. Alright, 3 raised to the 10 is a very large number, and then I divide that by 5, so 11809. I accidentally hit clear, so I have to retype it in. 3 raised to the 10, divide by 5, oh no, 0.8, alright, here we go. And it checks, I can plug that in. No problems. Right, the last one is where we've got to do a little bit of work to isolate my natural log. But again, it's just move stuff over and divide until I get the natural log by itself. So move the 1 over, so I get 9, divide by the 4, and so I get the natural log of x equals 9 divided by 4. I get rid of the natural log by taking e to both sides, right? Because natural log is base e. So the base e will cancel it out. So on this side I'll be left with x. On this side I'm e raised to the 9/4 exactly. And then again type that in the calculator. E raised to the 9/4. And so when you take e raised to the 9/4, it comes out 9.488 if I round 3 decimal places. And there's my final answer. Alright, we will do more solving logarithms and exponentials in the next section. We'll get to more complex cases. So these are the simple cases, which again you should understand. They all come from the fact that a logarithm and an exponential are inverses. Right? That's basically the reason why logs were created was so that we could do these types of equations. Right, we will stop there, and that finishes up 5.4. Right, then we'll go over our log rules and more equations in the next set of notes. Alright.